Hello, welcome back for a little bit more talking or a little bit more diving into how to factor trinomials where the a value is not 1. One thing I want to do is just start off by remembering that factoring isn't always breaking down a trinomial into two sets of parentheses. Sometimes all we're going to ask you to do is to find the GCF and factor that out. So if I look at these three terms, I cannot factor this into the two sets of parentheses that we've been doing. So in this case, my only question is all right, what do these three terms all have in common? And all of the coefficients, 2, -16, and 10, can be divided by 2. So 2 is a factor of all three. So that's part of my GCF. And I can remove 1 power of x from all three terms. Because 2 has x to the fourth, 16 is x squared, and 10 only has a single power of x. So 2x is my GCF, and my problem is done once I've filled out these last three terms. So 2x to the fourth, if I divide by 2 and remove a power of x, that term will just become x to the third. -16x to the second is going to become -8x to the first. Again, you can check that by go ahead and multiply those two together. You'll get -16x squared. And then finally, 10x, when I essentially divide by 2x, is going to become just a +5. So this is done because all we were asked to do was to factor out the GCF. Find the GCF, factor it out, you're done. Something we haven't seen in a while is, hey, here's a binomial. Here's just two terms, find the GCF, call it good. So 32 and 20 both have a common factor of 2, but 4 in this case is actually the greatest common factor. I can also remove an x from both terms, and if I do that, I'll be left with 8x in the first term, because 4x multiplied by 8x will give me 32x squared, and then -20x will reduce down to -5. So there are my first two examples, warm-ups, where all I has to do is factor out the GCF. We are going to get back into factoring trinomials like we did in the previous video or the previous lesson. But just wanted to remind you that sometimes it's just, hey, find the GCF, factor that out, you're good. Okay, so again, two examples where the A value is 3 for both of these, the C value is 12 for both of them, but the B value is different. Okay, I'm going to go to the one where the A value of 3 is actually a factor of every term. So all of these coefficients have a factor of 3. So that means 3 is a GCF. So just like the warm-up, I'm going to factor out the 3. This becomes x squared minus 5x plus 6. And now I'm going to factor this trinomial, this new version of my trinomial, and I'm going to try and get -5x in the middle. That is going to be x multiplied by x with a 3 on the outside. I need factors of +6 that will create a -5x for me in the middle terms. And I'm going to use -2 and -3 because here I get -2x and here I get -3x. And together that does equal -5x. So there is my factored version of that one. So 3 was a GCF. I took it out. We're good. This one, though, 3 is not a GCF because 3 is not a factor of 13. So I know the only way to make 3x squared is to multiply 3x and x. So I'm going to try this one without the box method. If you like the box method, you want to draw it in the open space, I highly recommend it. And then I need factors of +12. So I know that this number together with this number has to equal +12, just like 3x multiplied by 1x had to equal 3x squared. And then, again, we're going to keep in mind that -13x is what I want. And the fact that the 13 is negative tells me that my factors of 12, whatever I put in the blue, had better be a couple negative numbers. So I'm going to try -2 and -6. Just 2 and 6 is the first thing that comes to mind. Here I have negative 2x. There I have negative 18x. Together that makes negative 20x, which is not negative 13. So we're going to go back to the drawing board, get rid of the negative 2 and the negative 6. What happens if I reverse it? If I go negative 2 and negative 6, maybe that's what I need. There's negative 6x. There's another negative 6x. That's negative 12x. That's not going to get it done. So I have to try something besides 2 and 6. Maybe it's 4 and 3. Let's try 4 and 3, because remember, what the rule that I need to follow is I need to make sure that these numbers always multiply to positive 12. Okay. In this case, if I distribute this, whoops, not in highlighter, I get negative 4x there and negative 9x there. Negative 4 and negative 9 does indeed make negative 13x. Nice. So because negative 4x and negative 9x is equal to negative 13x, I know that this number combination is going to work for what we need. Now, if you hated watching that example because I wasn't using the box method, again, go for it. Live your life. Go ahead and use that box method to show it. Okay. So the one on the right, the first problem we did, the 3 was a GCF. Problem on the left, 3 was not a GCF, so we had to go to work. Okay. Here, we're just going to do a couple examples. It's going to be a real short video. I know the previous one was 20 plus minutes. This one is, we're going to keep it short. 6x squared. Whew. That one's tricky because it could be a 2x and 3x, or it could be a 6x and a 1x. But the good news is this right here, this positive 5, it's brilliant because there's only 2 factors of 5. It's got to be 5 and 1. So I almost, like, this is a little backwards, but I almost know that that's going to be 5 and that's going to be 1. I know this could be wrong, but I'm pretty confident that because everything is positive in this problem, there's no negative numbers at all. I'm pretty confident that that's got to be 5 and 1. And now it's just, is it 3 and 2 or is it 6 and 1? So I'm going to try 3x and 2x. I'm not going to highlight those yet because in green, because I want to check to see. Here's 10x. There is 3x. 10x and 3x makes 13. So we got lucky on this one. Sometimes you will just, hey, first thing you write down is the right answer. And then sometimes the first thing you write down is so far from the right answer, you almost want to give up. But we're not going to do that. We're going to keep working. So 3x plus 5 and 2x plus 1. Clearly, you do not need to have your answer highlighted, but I'm just doing that for the sake of the, color coordination and understanding where these numbers are coming from. Again, 12x squared minus 17x minus 7. That is a lot to look at because it could be 6x and 2x, 4x and 3x, 12x and 1x. So I'm going to instead take the fact that that is negative 7, and it almost certainly has to be a 7 and a 1. Now, the 7 and the 1 could be reversed. It could be negative 1 and positive 7. I don't know that it's going to be negative 7. But what I do know is that this 17 in the middle, my B term is negative. So it gives me a pretty good idea that I want more negative than I have positive. So I'm going to start with negative 7 and 1. For 12x squared, it could be 2x and 6x. That is negative 42x when I multiply. So this is probably not going to be right, and that's positive 2x. That would be negative 40. So that is incorrect. I could try swapping the 6 and the 2. I could go 2 here, 2 here, 6 here. That would give me negative 14x and positive 6x, which is closer. It's negative 8x, but that's still not negative 17. So that means now that I've tried 6 and 2 in both spots, and I haven't gotten either positive or negative 17, I got to try something besides 6 and 2. So let's go 3 and 4. 3 and 4. Here I've got negative 28x and positive 3x. That's negative 25, so that is incorrect. So far we're 0 for 3. Let's swap the 3 and the 2, or sorry, the 3 and the 4 around. So we'll go 4 here, 3 here. That is 7. Negative 7 times positive 3x is negative 21x. 4x times positive 1 is positive 4x. Negative 21 plus 4 is negative 17. So we found the combination that works. So now we'll just highlight. I got 12x. Let's double check to make sure we're not doing anything crazy. 4x multiplied by 3x does make 12x squared. And then negative 7 is what I get when I multiply negative 7 with positive 1. So 4x minus 7 and 3x plus 1. Again, if you want to put 3x plus 1 first, that's fine. So again, short little video, just a reminder of how this works. The first term, and you'll see the color coordination here. The first term times the first term has to multiply to ax squared. Your last terms in your binomials have to multiply to the c value, and then you just need to check to make sure that you get that middle term when you multiply. Thanks for watching.